Todo mundo aí me ouvindo? Dá um okzinho aí na tela para eu ver. Beleza? Fala, turma. Muito bem, é um prazer tê-los aqui. Fala, galera. Todo mundo aí me ouvindo? Deixa eu só dar um okzinho. Então é um prazer tê-los você aqui nessa tarde. Uma boa tarde a todos. Nós vamos iniciar da sequência aí no evento da Semana Nacional de Ciência e Tecnologia. Nós já tivemos hoje a abertura do evento na parte da manhã, com a nossa reitora fazendo a abertura. Nós tivemos uma palestra interessante, espero que tenham tido a oportunidade de ter visto, né? E tem muita coisa aí para frente, tá? Hoje mesmo tem muitos eventos aí acontecendo durante a semana, amanhã, depois de amanhã, nós vamos ter bastante evento aí acontecendo. Espero que vocês tenham se inscrito. E mesmo se não se inscreveram aí de última hora, vá lá no site, pega o link e participe. Essa é uma oportunidade que a gente tem, por exemplo, aí na apresentação de hoje, estamos trazendo alguém de fora que eventualmente não seria possível no modelo presencial. Dessa forma remota a gente consegue fazer isso. Então é muito bom, vamos aproveitar, né, isso. Bom, antes de eu apresentar o nosso convidado aí de hoje, o professor Vincenzo Schettini. Vincenzo é um amigo que eu conheço já há quase 4 anos. Né? A gente troca algumas informações e quase que semanalmente a gente conversa bastante. E é um professor de física que leciona na Itália, numa província chamada Bari, numa cidade chamada Monopoli. Se a gente imaginar a botina lá da Itália, fica no calcanhar da botina. Tá? É ali que ele se situa. E, além disso, ele tem um monte de coisas que ele faz. Até vou fazer a apresentação dele de forma diferente, porque é de costume nós apresentarmos. Olha, o professor tem mestrado nisso, doutorado naquilo, lê aquela, né, imensa lista falando sobre a pessoa. Mas ele é músico, toca violino, ele tem um coral, ele participa de um coral. Ele é membro do CERN. O CERN é uma organização que fica em Genebra, na Suíça, onde eles têm uns laboratórios com acelerador de partículas, essas coisas todas. Professor de física, professor de matemática, youtuber. O canal dele no YouTube, esse La Fisica che Piace, tem quase 150 mil inscritos. Né? Um canal que se fala em italiano e se fala sobre física, né? É de se elogiar. Bom, antes de começar, né, eu queria falar para vocês o seguinte: o Cristiano colocou para vocês aí uma lista de experimentos. Eu até trouxe aqui algumas coisas que eu vou usar também para fazer junto com ele, né, esses experimentos aqui em física. E sugiro, né, se vocês tiverem aí alguma coisa em mão, se vocês conseguirem levantar parte desses experimentos, é um copo, uma jarra de água, são coisas fáceis que você tem em casa, seria legal vocês participarem aí dessa questão. Toda a transmissão será feita em inglês, né? Ele não vai falar italiano não, porque o italiano está fora do meu alcance aqui. Então toda a transmissão será feita em inglês e eu imaginei que nós tivéssemos um tradutor, não temos, então eu não vou ficar traduzindo tudo que ele fala, mas eu vou falar algumas coisas importantes, alguns destaques, eu volto falando em português com vocês também. Mas vocês podem contribuir aí no chat, escrevendo mesmo em português. Professor, o que é isso? Fazendo as perguntas durante. Tá? Não se preocupe em esperar terminar, não. Pode fazer as perguntas durante a apresentação, que isso vai ser legal. Essa interação, ele gosta muito desse tipo de interação. Tá bem? Tá? Então, vamos lá. Vamos apresentar aí o professor Vincenzo Schettini. So, from now, I will shift to English to say hello to my friend our guest here, our guest speaker here, Vincenzo Schettini. Vincenzo Schettini, and I would like to introduce you in a different way, because, and in a common way, in a normal way here in Brazil, in a polite way for this case, we use my suit, a tie, and Vincenzo Schettini is from Italy, he's a master degree in something like that, and a PhD in someone else, but for me, I've told you're like my jack of all trades. Many things. You are a musician. You plays violin. He has a YouTube channel with over than 100 maybe almost 100,500
Yeah,
subscribers.
right.
Incredible, because he's speaking in Italy. Most of the videos are in Italy and talking about physics. Oh, that's incredible. And he has an acquire that presented for people during the Christmas time, I guess. And
Mhm.
teacher, he teaches math, he teaches physics. So you are my jack of all trades. So Vincenzo, I told the audience here today about how does it works, because I can't translate all the time our
Yeah,
conversation
yeah.
there.
But I have to say
Ask
that
them to interact to ourselves, okay?
yeah, I
So,
have to say,
up
first
to
of all,
you from now.
thank you, Alex. First of all, thank you so much, Alex, for inviting me and uh, wanting to share with me this experience, because for me it's so incredible to have the chance to talk to Brazilian people, even though I'm not so good at Portuguese. Sorry, but I got you. I got you what you said in Portuguese before. And I have to say, first of all, that I'm very, very impressed about my YouTube channel, because when I started my experience on YouTube, that was 4 years ago, just 4 years ago, September, you know, let's say 5 years ago, September 2017. No, it's 4 years ago. It's 4 years ago. I've never imagined to get 100,000 subscribers, let alone 100 and 30,000 subscribers. It's crazy, because it's physics lessons. It's in Italian, as you said, which is so weird, but it happened. It happened. It really happened, and I can't believe it. That's the thing. Besides, as you said, I'm collaborating with the CERN. I've been collaborating with them for more than 4 years. I started my journey throughout, teaching physics, high energy physics in 2016 at CERN, and I organize over there meetings with Italian teachers to let them the possibility to teach, some interesting physics, because I know that people like particles, people like modern physics, people are a little bit, bored to to listen to people talking about, the inclined
Let,
plane, the
let me
acceleration.
interrupt you just some because I'd like to explain for them in Portuguese,
Yeah.
maybe
Okay, okay, okay. Perfect.
the
I'm
most
gonna
important
drink
thing.
my tea in
Oh,
meanwhile.
go there. Então ele está dizendo aqui, primeiro ele falou sobre o canal dele do YouTube, né, que também para ele é impressionante, né, falando sobre tantas pessoas falando de física, né, ensinar física em italiano. É diferente quando você está ensinando em inglês. Né, em inglês o mundo inteiro quer aprender, né, então é muito mais fácil você ter pessoas assim, mas ensinar italiano é incrível, desde 2006 ele faz isso. E aí ele começou a falar sobre o CERN, né? O CERN é o Centro Europeu de Pesquisas Nucleares, uma coisa assim. Eu não sei muito bem a tradução de lá, mas fica em Genebra, na Suíça. E eles têm lá um acelerador de partículas. Então começou num programa onde os professores italianos, né, provavelmente são os colegas dele lá, foram convidados para participar, né, desse estudo, desses experimentos. Eu sei que ele também leva os alunos dele para lá. Algumas vezes eu já vi ele levando alguns alunos para fazer parte disso. Né? É claro, né, a parte da física que é mais interessante, mais legal, né, segundo ele, é essa parte da física moderna, né, as partículas, a questão do espaço-tempo, né, aquelas coisas que ele tem nos vídeos dele lá. Ok, Vincenzo, go on.
Perfect. In talking about particles, it could be, a little bit difficult to understand. Probably I'm talking to you students, I'm talking to you, thinking about particles, because probably you are gonna think, I don't know about physics. I don't know about particles. I don't know about energy. That's so huge. That's so difficult. It's not. And I want to show you why it's not. Because I want to use my whiteboard. I call this in Italian lavagnata. It's a fancy word to say whiteboard. You can see over here a formula, an interesting formula. Okay, I have a question for you. Do you know this formula? Do you know the meaning of this formula? Let's go. Let's write something.
Okay. Vincenzo, say it again because I was answer to Chris in the private chat. What did you ask for them? If they know this equation?
They know this equation. I want to read something.
Vocês já ouviram falar dessa equação aí, pessoal? Alguém conhece isso? Alguém já viu isso na vida aí, ó? E igual a mc ao quadrado? Sim ou não? Sim, né?
Yeah.
Tem ideia do que seja isso?
What is E? What is C? Because this is a very important formula.
Energia? Ok. Gustavo.
Ok, great, Samuel. Gustavo says energia, massa vezes a velocidade da luz ao quadrado. Bravo! Valeu, galera! Okay, that's correct. Okay, the important thing to know is here we have energy, and here we have energy, and here we have mass. The energy and the mass. Einstein was the first scientist to say that energy is equal to mass, and the equation that bounds energy to mass is this equation, E equal to mc squared, which means that the energy is equal to the mass to the velocity of light, speed of light squared. That's very important because this is the first start to think about that if you have some energy, you can create mass. But what is energy? What is energy? What is something that, tells you energy? What is energy for you? Answer my question. What is energy?
Eu estou perguntando assim, o que é energia para vocês? Porque ele mostrou na equação que a equação está dizendo, né, segundo Einstein, que era o limite máximo, né? Então, o limite máximo da velocidade da luz e coisas assim. A gente vai ver que pode ser que não seja, né? Pode ser que a gente tenha alguns elementos a mais aí em relação a isso. E que, a partir disso, você pode criar massa. Então, o que seria energia para vocês? O que você acha que é energia aí? Quem diz aí? Quem arrisca aí? Eric? Júlia? Pedro? Matheus? O que é energia para vocês? O que vai na sua cabeça quando fala energia?
Think about a form of energy that is around you.
Gabriel,
think about cars.
Gabriel says a base for some change.
A base for some change. No, it's okay. So it's Greek. Force of an object to do something. Okay, if I push an object, the object is going to move. Yeah. So movement is energy. Movement is kinetic energy, okay? Movement is kinetic energy. So if we have an object that is moving, that movement is energy. And Einstein says that you can convert, you can transform that movement to energy. But to do this with a huge object, it's very, very difficult. But if you have tiny particles which move at the speed of light, you can create mass. You can create other particles. Alex, if you want to translate, because I don't know whether they understand.
Então, é muito interessante. Você disse, então, que se você tiver pequenas partículas, né, de acordo com o que se sabe, você é capaz de criar massa. Então você está criando alguma coisa, está tentando talvez explicar a origem do universo, né? Como é que você cria massa ou cria alguma coisa. Teve um aluno que escreveu assim, ó, it would be the cost of to perform a job. Energy is like the cost to do a job, to perform a
Yeah.
job.
That's correct. That's correct. Because in physics, energy, it's the amount of something to perform a job. Job is a physics thing. I want to ask Chris to share my screen because this is the moment. Okay, perfect. Okay, now we can see what I just described because I want to share with you this interesting video, which is, almost 3 minutes. I want to share with you what is going on at CERN. CERN is the huge laboratory of physics settled on Geneva. It's in Switzerland, in Europe. This is the Large Hadron Collider. I want to, step back just one moment. This is the Large Hadron Collider. This is a circular collider. I was talking about particles that go almost at the speed of light, and they smash to each other to create other particles, other matter. Because as I told you, energy, you can transform energy to matter if you have things that are moving very, 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 very fast, almost at the speed of light. Okay, let's just see what happens, inside LHC, it's a Large Hadron Collider. We have a battle of hydrogen. You can create you can create a beam of protons, which are positive particles. These protons start to run around this small accelerator, which is the first accelerator, and then they increase on speed of light, and they go through the second accelerator. Is the proton synchrotron, is the second accelerator, okay? This is just a half a kilometer long. The third step, it's on super proton synchrotron, which is 7 kilometers long. This is just almost the speed of light. The last step is, divide. Okay, let's see that. The last step is divide the beam of particle in 2 beams. Let's see, 1 and 2. We have 2 beams, okay? These beams are going to the speed of light very, very, very fast. And there is a moment in which scientists decided to start smashing the particles. Okay, this is a moment in which particles collide over here. This is one of the 4 experiments. And you can see a lot of, thousand of particles going outside.
Estou falando que nesse momento aí é onde, porque não é só o acelerador, ele mostrou todo o processo de aceleração de partículas, os prótons lá, etc. E ali era o momento onde colide, né, na colisão dessas partículas e gerando uma quantidade enorme de outras, né? Ok, Vincenzo. That's good. Going on.
We have 4 different experiments at CERN. This is the main experiments.
Qual experimento? Eles fazem 4 experimentos lá.
Perfect. CMS, Alice, Atlas, and LHCb. Okay? CMS and Atlas are the 2 ones that discover the Higgs boson in 2014, if I'm not mistaken. It was 2014, something like that. Do you know what is the Higgs boson?
No, I don't know. To explain to them.
Ask to your student. Probably one of them know.
What's the name of this?
Higgs boson. I'm gonna write something on the chat.
I've heard something about that one, but I don't know. I'm not sure. Alguém sabe o que é um boson?
boson. The Higgs boson is an important particle that gives matter to the other particles. This is the Higgs boson. This was the most important discovery at CERN in 2014. Okay, now you are seeing the accelerator working, and the important thing to do at CERN is collecting the data, because each hour they collect 2 petabytes of data. This is a huge quantity of data, and they need, supercomputer to collect this data. This is probably interesting for you, Alex, because you work, as a informatic teacher, I guess.
Yeah, they're starting talking about the quantical, computing quantical computing.
Okay, perfect. So the thing is that CERN, it's not possible for CERN to collect all the data they produce every day. So they are gonna, they came up with an idea. They started to share the data around the world, okay? From CERN to Budapest to other city, probably even to Brazil. I don't know, because there are a lot of computer centers around the world that are working with CERN to collect the data, to analyze the data, to discover new particles, to discover new physics. This is huge. This is incredible. And this is something in which are working thousands of scientists around the world.
Gustavo is asking about the boson of Higgs, the Higgs boson. That's it?
Yes, the Higgs boson, yeah.
Mm-hmm.
Perfect. So when I talk about this, it's incredible, because I think that if Einstein had had the possibility to see what is going on at CERN, he would have, smiled and, enjoyed a lot, because starting from that thought of him, all of these things came to life.
Yeah.
Just because of Einstein, just because of him. That's amazing. That's incredible.
It was just an idea, just a theory, and now you can prove that. Yeah.
Yeah.
Tá dizendo que se Einstein estivesse vivo hoje para ver isso, seria uma coisa. Ele ia ficar maluco com esse negócio.
Oh, I want to say something else about CERN and all the things that are going on over there, because since I have the possibility to go to CERN twice a year, 3 times per year, I created playlist dedicated to CERN, which is possible to see on my YouTube channel. So now it's the moment to ask your student to subscribe my YouTube channel.
Okay.
That's perfect. Okay, the name of the channel is...
Just a minute. Ele está dizendo o seguinte, que é um momento de eu passar para vocês, né, vocês se inscrevam no canal para ver mais vídeos, ver mais coisas do Vincenzo. Né? A gente sabe que o YouTuber, ele vive de inscrições, né, de pessoas que se inscrevem no canal. Então, quem puder aí, galera, dá um clique lá, se inscreva e curta os outros vídeos dele lá. Eu vou colocar aqui depois o link. Go on, Vincenzo.
Yeah, you're gonna find a lot of different video about CERN, because it's gonna be in Italian. I guess that for Portuguese people, it's not so difficult to understand Italian people talking. Is that right, Alex?
Sim, yes. Português é mais ou menos, se eu falar bem devagar, é provável que você vai entender eu falando. Então, português tem algumas coisas assim em comum. Eu também estou tentando falar um pouco de italiano, mas não é fácil, não. Sto cercando di capire alcune conversazioni in italiano, però...
Bravo!
Capisco più o meno. Capisco più o meno.
You have to know that Alex and I have been talking to each other for probably 4 years. And Alex is very interested on learning Italian. Am I right, Alex?
Yes, you're right. But it's not easy.
It's not easy. It's not easy, but I know that you're gonna make it. Okay, so this is just about CERN, about physics particles, which is amazing. But physics, it's almost simple to understand if we talk about, something that we know very, very well, such as the strength, the height, the weight, the forces, the formula that probably you study at school. I want to ask your students, Alex, whether they study physics at school or not.
Ele está perguntando se vocês estudam física na escola, né? Porque é diferente deles lá. Eu não sei também como é que é o nível lá dentro da graduação e etc. Vocês são estudantes de física aí? Que ano vocês estão aí em física? O que vocês já viram de física? Ou talvez a pergunta legal seria qual é a parte mais interessante da física que vocês acham aí? Coloca no chat para eu passar para ele.
Okay. There are a lot of people are writing sim. What does mean sim? Sim is a sim? Is a sim? Sim?
Sim.
Sim.
Sure. Yeah.
That's fancy. It's fancy. Sim.
Yeah.
Wow.
Sim.
Okay. So, there are a lot of people that study physics. Allora, I want to try to do with you some physics experiment. We are going to do 3 different experiments. So, I want to ask Chris to cut off my screen. Okay, perfect. Because we are ready to start our experiment. Okay, the first one, I want to involve all of you to do the experiment with us, with me, with Alex, because Alex know what what we are gonna do, but you don't know.
Okay, tem um rapaz. We have a guy here, Agnaldo. Are you seeing Agnaldo here? He told us. He says he is in a 5th semester in physics. He's at the university studying physics. So that's
perfect. Good. Perfect. So. Aguinaldo Antonio Rodriguez. Perfect. So Antonio, let's do the experiment with us. Okay, we need a jar, some water, and a tangerine.
Tangerine.
Okay, a jar.
I have
some
one
water
here.
And a tangerine. Perfect. So the first, Alex, do we have to wait students to collect the material? What do you think?
Yes, because just at the beginning of our presentation here, I suppose they're in the chat box for them the list. But we can say them. I'll tell them in Portuguese, okay? Bom, nem em português eu sei o nome disso aqui, mas é uma jarra. Se você tiver uma jarra de suco em casa, uma coisa transparente, uma jarra, isso aqui é como se fosse um vaso, né? Nós vamos pegar uma tangerina dessa aqui, ou se você tiver uma laranja, se você não tiver uma tangerina, tudo bem. Só que daqui a pouquinho nós vamos usar a mesma fruta descascada, né? Então, para descascar a laranja fica mais difícil. Né? To unpeel the orange is more difficult. Because it could be an orange, but it's difficult to unpeel. Yeah.
It's too big. The orange is too big. The tangerine is perfect. Tangerine is spot.
Okay.
Besides in Italy, it's almost winter over here. So the tangerine is the perfect fruit to buy at the farmer's store because we have tangerine in winter in Italy. Yeah. So, let's start, Alex. You are going to do the experiment with me. Okay, perfect. The first thing to do is put the tangerine in the water, and we are going to see what is happening. Okay. It's the same thing.
Oh, it's
the tangerine, it's not, going down. He's up on the water, okay? The second part of the experiment, take the tangerine, peel the tangerine, okay? We are gonna take the tangerine, we are gonna peel the tangerine. One moment, because I need a tissue.
You must have been done this before.
Just to dry my tangerine.
Okay, no problem. It's easy to
Okay.
unpeel. Vamos descascar a tangerina aí. Quem pôs lá, vamos descascar.
Peel the tangerine. Okay. Perfect.
I'm ready.
Perfect. And now put the tangerine on the water.
Okay. Plop down.
Okay.
Let me plop it down. Okay.
Okay. The tangerine just plopped down.
Oh,
He went down. So the question is, why did the tangerine go down right now, and why it didn't go down before?
ok.
What is the difference? What is
Ele
the
está perguntando
physics?
para vocês aí, ó. Ele quer saber, ó, dá uma
Something-
ideia. O que, que aconteceu? Por que que essa aqui que eu vou colocar aqui agora? Eu tenho duas, né? Essa aqui.
Okay. When I go this in my in my live lesson, I'm used to saying via le telefonate, which means let's go, answer the question.
Okay,
Via le telefonate.
Ok, pessoal, escreve aí. Por que
Alex,
uma
sorry,
boia e a outra afunda?
Sorry,
Qual é o
meanwhile,
princípio físico que está acontecendo aí?
Alex, sorry, meanwhile we wait for the answer. There is Tiago Caparelli that says, Alex, la mia famiglia viene dalla Calabria, mi piacerebbe molto imparare anche da lui a migliorare il mio italiano. Allora, Tiago, I have something to share with you. There are a lot of people around the world that follow my channel to improve their Italian, because they say that when I speak Italian, I speak, not so fast. So I wanna ask you to follow my channel, even improve your Italian, to enjoy physics, or why not to improve your Italian?
Thiago Caparelli is one of our teachers. He's in my colleagues in the same, because we teach computer networks for students. Most of them here are from this course, from the computer network course, and he is one of the teachers there. Thiago Caparelli.
Tiago Caparelli, perfect.
Caparelli is a surname.
Okay, so I'm waiting for the answer. I'm waiting for the answer because I want to ask you what did happen to the tangerine.
Okay, we have one here.
Greek Enrique.
Gustavo Henrique. He says the density before was bigger than when we were peeled. So it's talking about the density. Is it right?
Yes, it is. This is one of the possible answers. The density before was less than the density after. Because when the density, sorry.
Can I eat my
yes,
tangerine? Oh,
you have to.
Completely wet. Completely wet. Did you drop?
I used my spoon.
Oh, you used a spoon
to take the tangerine. When the density is more than the density of the water, then the tangerine will go down. But there is another answer. There is another possible answer.
There's an answer on the screen. Are you seeing?
Let's see if someone, give us another explanation, because there is another explanation. Gabriel Pereira Santana says because of any property that the tangerine skin has. The tangerine skin is more or less dense than the water. So in average, the density of the tangerine, when the tangerine has its skin, it's less than the density of the water. But this is all about that density. There is another possibility, and I'm gonna show you what with my lavagnata. One moment.
Okay, write down.
There is a force, there is a strength that appears when you put something on a liquid. Okay, this is water. Okay. And this is, for instance, the tangerine. Or maybe this is me. This is me at the beach, because Alex knows very well that I like going to the beach every day, even in winter. I like swimming a lot. Okay, sorry, I'm digressing. When you go in the water, there is your weight, which is a force, it's a strength, it's a force, and there is another force which goes up.
Ele tá mostrando a relação entre as forças. Então, quando você tá. Ele mostrou ali, né, brincando que isso não era a tangerina, nada, era ele nadando na praia, que ele gosta muito. Então, ele tem o peso do corpo dele que exerce uma força para baixo, mas tem uma outra força para cima que ele colocou ali.
Perfect. Even when we walk in a room, the air is pushing ourselves up. But the thing is that the force of the air, it's very, very thin. Okay, it's small. It's very small, the force of the air. This is not the same with the force of the water. So when you go in the water, there is a force that pushes you up. In fact, if you think about yourself swimming, you can see yourself more light, you know what I'm saying. It's a wonderful sensation when you grab someone on the water. The weight of them, it's less than the weight of them, outside the water. This is the thing.
Ele falou que a gente percebe isso quando está andando na piscina, você se sente mais leve. Até se você quiser pegar uma pessoa, você consegue, mesmo a pessoa sendo pesada, né? Você aproveita a força, né, que vem de baixo para poder ajudar a segurar.
Ok.
Vamos lá.
Addictioning these two forces. If these forces is more than this, then the tangerines is gonna go up. If this force is less than this, the tangerine is gonna go down. So it depends on this. It depends on the density, of course, but the density means also that this tangerine is gonna go up or down, relating to the addiction, the combination. Yeah, I mean the combination of these two forces. This is the Archimedes principle. If you want to Google, you can find Archimedes principle, which explains this situation that happens.
But Vincenzo, one could imagine that. Oh, but the tangerine has the same weight, and when I unpeeled the tangerine, he's less weight than before. So there's not about the weight. It's not about weight. Okay.
No, it's not about weight. It's not about weight. It's just about the force that when students said that it happens because of the density, they are right. They are right. But we have to think about that. If something changes, then the whole situation changes. If you think about a boat, a huge boat, the boat flows, in the water. But if you create a hole, then the general density changes. The weight is the same, but the combination of the two forces changes as well.
Okay.
And then all the things
and then
change.
It sinks.
Yeah, it sinks. Perfect. Okay. There is someone that is saying Eureka.
Yeah.
Yeah. Okay. The second experiment.
Okay.
The second experiment. Okay, you have to take a bottle of water.
I have one here.
Okay, you have to put the water in the bottle. So I'm gonna do that just right now. One moment.
My bottleneck is different than yours. It will be work. I hope so.
Sorry,
The bottleneck is different than yours bottle.
Yes, probably you are gonna have a little bit difficult to do that.
Oh, I will do the same in what you're doing because I would like to provide a more safe condition for me here. I have one too. Okay. Of course, I trust in you, but just for guarantee.
Okay, probably I'm gonna add much more water, because as you can see, there is no water. Just one moment, okay?
Ok,
I'm
go
gonna.
there.
Perfect.
E aí, pessoal, estão gostando? É assim mesmo, tá? Ele, inclusive nas apresentações dele, é sempre assim, é sempre meio improvisado. Então, até me pediram para mandar um roteiro da apresentação. Falei, não sei o que pode acontecer durante a apresentação, então não tem como fazer um roteiro, ok? Eu vou me precaver, viu? Eu sabia que estava faltando alguma coisa, deixei aqui do lado, uma bacia.
Okay. Okay, I'm ready to continue my experiment. Perfect. Okay, you have to fill up the bottle completely. Okay, it's completely filled up,
That's
and
right.
then you have to take just a little piece of plastic like this.
Esse plástico é aquele. Vocês já tiraram um xerox de livro, né? E tem aquela capa que você escolhe a capa fumê, capa transparente, etc. Né? Parecido com isso aqui, ó, uma capa plástica.
Okay, perfect.
Eu já cortei um pedacinho aqui que já dá o tamanho. Você tem que cortar mais ou menos um pouquinho maior só que a boca da garrafa, aí, se você estiver usando. Se você tiver aí uma garrafa, pode ser qualquer uma, tá? Que funciona. Até uma garrafinha de água, assim, funciona. Se você tiver.
Okay, now put the piece of plastic, yes, on the bottle and turn down the bottle. You have to turn down the bottle without any kind of hesitation.
No.
Good luck to you and me.
No.
Okay, are you ready?
I can avoid hold on this because if I try to turn on it, you drop on this thing.
Okay.
Can I?
3,
You do?
2, 1, let's go.
Oh, I mess up here. Okay.
Yeah. It works.
Okay.
It's working. It's working. The water is still there, and I want to remind you that this is just a little piece of plastic. Just a little piece of plastic. So the thing is, what is happening over here? What is happening? This is physics, but what? Could you explain this to me? Okay, I'm waiting for the answer right now.
Okay.
I'm very happy that it worked for you too, because the neck of the bottle.
But I was afraid. I was afraid, and I take care, a lot of care to turn the bottle.
Yeah.
Okay. Oh, if I remove the water, just to show them that it's not a magic, okay? Oh, okay.
Perfect.
It's not a magic.
Yes, I'm gonna do the same. I'm gonna do the same.
It's not a magic.
Okay. Okay. What is going on over here?
Ele está perguntando o que aconteceu. Tem uma resposta, deixa eu ver uma ali. O que aconteceu, pessoal? Por que a água não caiu? Por que a água não caiu?
Por que a água não caiu?
Yeah.
Ditelo. Yeah.
Greg says the bottle needs air for the water to come out.
The bottle needs air
Air.
or the water to come out. L'acqua ha bisogno dell'aria per uscire. Yes or not? Okay.
Let's work more.
Let's just try to think. It's, we are not in a rush. There is Luis Antonio who says forza de agua. Okay, but of course the water is doing something because there is the weight of the. Aguinaldo said pressao. The pressure. Yeah, the pressure. Yeah.
Luis Antonio, the pressure of water.
Pressure. It's not the pressure of the. It's not pressao de agua.
Pressure.
It's another pressure.
It's against that one.
There is another pressure. But what? It's not because of the water.
Pessoal, aproveitando para dizer, inscreva-se no canal do Vincenzo, mas inscreva-se no canal do IFTM também. Não se esqueçam. Oh, you have one answer here from Clara Maria.
Clara Maria pressao atmosferica. Clara Maria, ding ding ding. Brava. You're right. Just a moment. I'm gonna explain, this thing by showing something by using my lavagnata, my whiteboard. Okay, this is the situation. There is the bottle of the water. There is the water inside the bottle, and of course, the water has a weight. Okay, so there is the weight of the water that is pushing, on this point. But there is also the atmospheric pressure, okay, that pushes here, all the way, and even here. And the pressure, the atmospheric pressure is just like more than 10 meters of the water. So if you imagine a bottle of water long 10 meters, that is the weight of the pressure of the air. It's incredible. This pressure is the atmospheric pressure. We don't experience this situation of pressure on us because the pressure goes from outside to inside, from inside to outside. This is the thing that we don't experience, this pressure. But if you do this experiment, you can see with your eyes that the atmospheric pressure is huge. It's a huge number.
Oh, everything is about pressure, so.
Yes,
the last case is almost this. We have something like that too, because you are talking about density in the first experiment. But what happens in a case when you have a tangerine with the same density to the water?
This is an interesting question. When you have a thing, or maybe a tangerine that is the same density of the water, you can put the tangerine in the half of the height, and he is not going to move. He's gonna, stay there. It's very, very, very difficult to create such an object with the same density of the water, but it's possible. Probably there is something on YouTube. You can try to find something like
does it float? Does it sink? Okay.
Yeah. So if you think about the Second World War, there was a submarine, a huge metallic
iron.
Okay, and they use that object to go on the water, to go down, to go up, changing the density of the object, basically. Yes, changing the density of the object.
how it works, I guess, that submarine works, because he can float and he can sink.
Yeah, perfect. Yeah.
Good example.
Okay, let's
Okay,
go with the third experiment. Okay,
third experiment.
that's gonna be the most um, exciting one. Yeah, because
Let's
it's
try.
really weird. Okay, you need to do the experiment. You need a spoon, a fork,
Okay, I have here.
a tooth. I don't
Toothpick,
remember the name.
toothpick, toothpick. You say
Toothpick,
palito de dente.
pallito de dente.
Yeah.
Okay, pallito de dente. It's better. Pallito de dente. A glass, just a glass.
Oh,
Okay.
you are. It will work
It's
in
very,
your glass
it's
because
very.
more. It work in my glass. Do you think it will work?
Yeah, it's gonna work. It's gonna work. It's a kind of easy to to grab these things at home because it's a spoon, it's a fork, it's just palito de dente and a glass. It's very very easy. Okay, so
Vai lá, pessoal. Vai lá na cozinha e pega um garfo, uma colher, um palito de dente e um copo. Ou se tiver uma taça é bom, mas se não tiver. Ah, nós vamos precisar também do lighter lá do isqueiro, né? Um isqueiro,
okay.
um fogo.
Alex, are you ready to start?
I will do my best. Okay, we have everything here.
You have to you have to create a sort of block between the spoon and the fork, like this, like this. Okay. Okay.
Okay.
You have to block one in another.
Okay.
And then just use your palata de dente.
Palito.
Palito de dente. Okay. Put the palito de dente over here. Okay. Put the palito de dente over here. And just, pose the palito de dente on the glass.
Oh, my God. Okay. It's magic.
I was almost there. One moment. Because it starts to, to oscillate up and down. That's not working. Yeah, it's working. You're perfect. Bravo, bravo.
I can't breathe around this. I stopped breathing.
One moment.
Vou parar de respirar aqui para não cair.
Bravo, bravissimo. Ok. Okay. That's right. Could you explain this? Via le telefonate. Let's answer.
Aproveita para tentar explicar o que aconteceu, por que esse trombolho aqui, esse negócio todo está em equilíbrio aqui, não está caindo. Depois eu vou pegar um ângulo mais aberto, vou levantar meu computador para vocês verem que a colher não está aparecendo, mas não está escorada em nada. Depois eu vou levantar aqui para vocês verem. Okay, Vincenzo, and after that, what we have done?
There is another thing that we can do. We can use a lighter.
Lighter.
Do you have a lighter?
Yes.
Okay, you have to burn both the sides of the palito de dente.
There is a hint to start for the one another, or it doesn't matter?
No. Doesn't matter.
Okay, so I'll try.
Yes, try the first and the second one. Perfect. If
I will cross my fingers too, because Oh, can I set on fire again?
Yeah, you can. Yeah, you can. Even in the other side.
And the other side, it's in the end of the spoon.
It's almost okay. It's almost done.
Maybe
Okay.
I couldn't.
You made it. You made it. You made it. You made it.
Okay.
It's okay. Okay. The thing is that it's not going. It's the same. So the equilibrium. There is an equilibrium that created. But the thing is, what is happening? What is happening over here? I'm just reading lista de presenza. Basta, just this. I want an answer. That's incredible.
Oh, I touching the spoon.
Ok, over here. Allora, Clara Maria, meglio che a show o centro de massa. Could you translate for me, please?
It's she guess it's the mass center.
Yeah.
It's about a mass
correct.
center.
That's correct.
Correct?
That's correct, because we call
this incredible, isn't it? It's incredible.
This is incredible because it's kind of something very, very exciting. Gustavo says, pensieri misso relazionando centro de massa, e Gabriel, the gravity center on the spoon and the fork together is in the toothpick. Yes, it is. You're right, Gabriel. Bravo, you made it. So basically, we have an object which is made of the spoon and the fork and the toothpick. That's very difficult to pronounce. Toothpick. Okay. In average, the gravity center is located on the position of the toothpick, in the middle of the toothpick. And this is just the equilibrium, because if you know where is the gravity center of an object, you can suspend that object no matter the side. No matter the sides. No matter the sides.
Diz que é questão do centro de gravidade, igual o Gabriel colocou aí, centro de massa também, como a Clara Maria colocou. E que o centro de gravidade está no palito, né? E se você descobrir esse ponto, esse centro de massa, você pode colocar em equilíbrio qualquer coisa, independente do tamanho que seja.
Oh, this is interesting. Talking about, the gravity center. Mm-hmm. Do you know what is the Torre di Pisa?
Of course.
I'm asking your student.
Torre di Pisa.
Torre di Pisa. Chris, if you can maybe write on the internet Torre di Pisa and share your screen so that we can see the Torre di Pisa. Maybe someone doesn't know what is the Torre di Pisa. The Torre di Pisa is a building that was, how can I say this in English? Crollare. Wasn't going down, was going down. That was going down. And they changed. If you think about this object, the gravity center of this object is here, okay? In average, it's in the middle. Okay, if you evaluate the line of this object, it's very, very, very close to this point. It's very, okay, Torre di Pisa, bravo. It's very, very close to this point.
Oh, let me see your image. Cristiano, põe aí
Perfect.
uma imagem maior para a gente ver. Nós já vimos a Torre de Pisa. Vamos
Okay,
ver de pertinho.
you can cut off the image. You can cut off the image because we just saw the Torre di Pisa.
Yeah. Pode tirar, Cristiano. Tenta colocar ele lá. Isso, vamos ver.
Perfect.
Maior ali para enxergar.
Okay.
Aí, valeu.
This is the moment in which the object is gonna fall. Okay, this is the object is gonna fall because the more he inclinates, the more there is the danger that it's gonna fall. But if you change the density of the object, because if you think about the fork, the spoon, the toothpick, the density, it's not the homogenic density because it's a weird object. If you put some iron over here, and if you change the density of the Torre di Pisa, then the gravity center, this point, is gonna move. Okay?
Olha só, isso é interessante. Ó. Ele está dizendo o seguinte, que se você... Ali está um ponto, né? Um ponto central ali. Então ele mostrou uma linha passando ali na vertical, é por isso que ela não pende, ela não cai. Mas se você alterar a densidade, colocando mais ferro, colocando outros objetos lá dentro, sei lá, mais pessoas, se você mudar alguma coisa, você vai deslocar esse centro para um outro lugar. E se isso sair fora, né, daquela linha, ela cai. É isso.
And you can save the Torre di Pisa if you do that. And they did it. They did it. They didn't create a sort of external structure so that the Torre di Pisa can stay over there. They changed the density of the Torre di Pisa, and this is the reason the Torre di Pisa is still there. Yeah, basically. Okay, Alex.
Let me ask you. They did something in Pisa Tower to shore up or to
change the inclination.
Yeah, they did some engineering procedure to change something to avoid the Pisa Tower fell down.
Of course they did it, but they do not want to change the inclination, because if you think about the inclination is the beauty of that tower. So if if you move the tower, if you put the tower, vertical, it's gonna be completely not interesting to see. There are a lot of people that come to Pisa to see the tower because it's inclined.
Oh, incredible.
Okay. Allora,
let's see if you have some questions here before finish. Vamos ver. Pessoal, alguma pergunta? Se quiserem perguntar alguma coisa para ele agora, referente ao canal, referente à profissão dele, né? Eu disse que ele era músico, tem um coral, tem um canal do YouTube. Sobre qualquer coisa, se quiserem perguntar, aproveitem agora, antes que a gente termine. Conseguiram fazer os experimentos aí em casa? Vocês pegaram aí os objetos?
In fact,
não é fácil não, viu?
In fact, I'm curious to know if whether they did the experiment. Meanwhile, if Chris shares my screen, I can show the students my channels, because we are about to wrap up. Okay. If you want to follow me, of course you can follow me on my YouTube channel, which is La Fisica che ci piace. You can follow me on Instagram, which is La Fisica che ci piace, on Instagram too. You can follow me on Twitch, because I opened my Twitch account, maybe 1 year ago, but I'm working a lot of Twitch. I'm doing live every Monday.
Here in Brazil, the teenagers are using more the TikTok. Do you have a TikTok?
Yes, of course, I have TikTok, and I got more than 200,000 subscribers on my TikTok. Yeah. I'm sharing on TikTok. On TikTok, I'm sharing my physics lesson, and I'm even doing some, quizzes. I'm talking about history. I'm talking about cartoons. I just talked about Dragon Ball. which is a beautiful manga that I used to see, that I used to watch when I was a child. I talk about mathematics, solar system, English, languages, you name it. Because as you know, Alex, I'm patient. I like talking English. I like learning new languages. And I decided to start a new experiment on my TikTok account. Yeah.
Okay. Let's try to answer some questions here.
Yeah,
Gabriel,
perfect.
how did
I'm
you
ready
got
to.
into CERN? You have explained it at the beginning, talking about how do.
Yeah. Okay. Actually, I applied 5 years ago. That was 2016. I applied to go to CERN for the first time because I went there for the first time in 2016. And I decided, to update myself about particle physics, high energy, because, I'm a physicist, I'm a teacher, but I didn't know what was going on CERN. And then I decided to apply. I was very, very happy when I got email and they were like, you got it. You have to come here. And I was excited. I was very excited. And that was the first time for me. There is a possibility for teachers to go to CERN every year, for Italian teacher, for teacher from French, from German, from other countries. Maybe, probably not from Brazil, but I'm not sure. Probably there is a program for Brazil too.
Ok, ele disse o seguinte, eu vou tentar resumir porque foi muita coisa desde o início, mas que ele conheceu esse programa em 2016, provavelmente, né, ele tem certeza disso. Ele sempre foi, ele era professor de física, mas ele queria aprender mais, então ele queria conhecer mais coisas, principalmente dessa área relacionada a partículas, essa parte da física moderna. Né? Então, ele queria, como se fosse uma pós-graduação, ele queria fazer um curso a mais, né? Fazer um upgrade, como ele disse. Né? Então, queria melhorar nessa área. We have another one here.
I'm pretending to understand when you're talking in Portuguese.
When did you are interested about physics? When did it came for you? When you was a child? Why physics in your life? How it happened?
That's a difficult question to answer because when I was a teenager, when I was studying at college, at high school, I thought that physics was a challenging subject to follow. And since I was interested on challenging things, I decided to continue to study physics because I studied physics. I used to study physics when I was at high school, in my high school. And I used to study mathematics. And there was something, challenging and mysterious related to physics. There is another thing to say. When I was very, very young, I used to watch sci-fi, fantascienza, sci-fi, I don't know how can I say fantascienza in English. It's, Alien, Star Wars, those movies. And I was, I fell in love with Alien. And there was something about science inside the movie, okay? I saw that there was something related to science because there was something real over there. And that was another reason that, put myself close to physics, close to mathematics.
Ele sempre gostou, isso foi uma paixão, né? Ele está dizendo que assistiu o sci-fi. Probably you know this one, because I don't know the name of this in Portuguese too, the sci-fi. And esses filmes de sci-fi, a gente diz a ficção científica, então ele sempre gostou, né, desse tipo de coisa, né, tá sempre próximo dele isso. Então é uma paixão, a gente descobre isso e acaba gostando. Né? E ele tem uns vídeos interessantes, ele falou desse negócio de alien, né, de será que existe vida além da Terra, né? Então ele tem um vídeo muito legal lá no canal dele, do YouTube, falando sobre isso, né? I saw that video. I watched that video you posted some time ago.
Yeah,
Very good in production, and it was almost there in Jupiter. I don't know.
yeah,
Talking
yeah,
about
yeah, yeah, yeah,
the
yeah.
ovnis and ETs. Let's see. Ok, o Pedro não conseguiu fazer, Pedro, nem a Júlia. Oh, não é fácil não, tá? Eu também aqui vou te dizer, eu cruzei os dedos aqui para conseguir fazer isso. It's not easy.
What did Julia say? Aquí también now? What does it mean?
Oh, he didn't get the. He was unable to do this.
Ah, okay.
To balance to balance the toothpick and the fork is not easy.
O palito de dente, now equilibrio, garfo.
Yeah, the palito de dente, the toothpick, doesn't balance with the fork and the spoon. She couldn't balance.
You have to try. You have to try.
You.
You have to try. You know, keep trying. Keep trying. You're gonna make it.
Have to use your. Okay, I will say it again. I try to do it again.
No, it's not gonna work because if you do the second time, it
doesn't work.
no. Just I'm joking.
Let's see just one more here. You have to choose this fancy. Você precisa escolher esse buraco do meio aqui, ó. Coloca só a pontinha do palito. Eu não sei se é uma superstição, mas eu sempre coloco a colher pro lado de lá. I don't know if it's a superstition. But I just use the spoon over there, the other side. Tá vendo? A gente segura mais ou menos, ó. As duas coisas.
You have to work with your hands. Very, very slow. We are not seen. Probably you have to change the position of the camera.
It was a luck for the first look, for the first side. Doesn't work. Maybe the body center.
Yeah, the body center.
I can't find the body center here.
By the way, the name of the gravity center in English is gravity center.
Gravity center.
It's the point in
body
which
center is another thing about triangle.
But
okay, I did.
Actually, okay, perfect. Oh, wow.
Okay, I did it
you
again.
You are perfect experimental scientist, Alex.
Okay.
Bravo, perfetto.
Okay.
Actually, the name of the gravity center in Italian is Baricentro.
Oh.
E Bari, it's a city very close to me. Yeah, because we
it's
have.
Not the same in the body center of a triangle. It's not the same of the body center of the triangle, because in a triangle you have a body center too. It's not the same thing.
I guess not, because we are talking about gravity center, which is the center in which you can, draw the vector, the weight. Yeah.
They are talking about the poster behind you, this image
Dragon
behind
Ball. There is someone that is talking about Dragon Ball. We can follow that.
Que falou de Dragon Ball? Eu gosto muito de animes e mangás. Do you like this kind of animes and mangas? I don't know if the name is in English. This kind of draws, in Japanese draws, this kind of things.
I like them too.
Yeah?
Yeah. I'm completely into manga and a lot of things related to them. In fact, I'm, creating some some questions on my TikTok account. And there are a lot of people that are answering my questions related to manga, to Dragon Ball, meaning that there are a lot of people that are, that like.
Okay,
manga.
And there are people here that are curious about this post about behind you. What is this image? What is that?
This is London. This is the street of London. I can show you. This is the bus. This. If you go to London, I don't know whether you've been to London. Maybe not. This is the bus. This is typical from London, and I happened to buy this from IKEA.
no.
Do you have IKEA?
They are telling me that it's not that one. Oh, the other one, because that's writing something there. I didn't realize that.
Okay, these are
Okay.
okay. We know we call them diabolic, which is it's a comic. It's a comic. Yeah, diabolic.
Okay,
Yeah.
I was supposed that
Okay.
was
I
the
thought it
London.
was over here. Yeah, she was asking over here. Yeah.
Okay, Vincenzo. Thanks a lot. I'm I'm very pleased to have you here today. We've tried to do this many times ago, but we have the opportunity now. So I would like to congratulate you because it's very interesting. I learned a lot, and I suppose they learned a lot too.
Can I do a last thing for all of you?
Okay,
Just I need 1 minute. Just 1 minute.
ok, you have a minute. Ok, pessoal, estamos quase no finalzinho aqui. Se não tiverem mais perguntas, espero que tenham gostado dos experimentos, tenham aprendido alguma coisa aí, né? Ou confirmado alguma coisa que vocês já sabiam. Foi muito legal aí a participação de vocês. Achei bastante legal vocês terem interagido, né? Não ficar só ouvindo a palestra, né? Fazer uma coisa assim mais legal. Vamos ver o que ele vai trazer.
Voilà.
Ah, you play the violin. Okay.
Just something, because I used to play violin. I graduated in violin probably more than 20 years ago. And as you said, I keep doing music. I keep playing music with my gospel choir. And sometimes I happen to study violin, just for you.
Okay, play something for us. Bravo, bravissimo.
That was not a big deal. Just a couple of notes. Just to say, just to tell you thank you, because I'm very happy to to stay here, to stay with you, Alex. You are an incredible friend of mine. Thank you for sharing with me this meeting with your students. I'm very, very happy.
Ok, então pessoal, agradecendo aí a participação de todos vocês, espero que tenham gostado. E aproveitem-se para se inscrever no canal do YouTube do Vincenzo, também no nosso canal aí do IFTM. E aproveitem mais, tá? Isso aqui é só uma amostrinha aí do SNCT do IFTM. Aproveitem mais, né? Tem muito mais coisas aí para fazer. Tá? Espero que tenham gostado. Ok? Nos vemos na próxima. Ci vediamo domani, probably.
Bravo.
Maybe domani.
Maybe later. Me and
Maybe
you
later,
just
okay.
calling.
Ok. Muito bem, podemos encerrar então.
Bye.
Uma
Bye,
boa
all of
tarde
you.
para
Thank
todos.
you.
Tchau, Vincenzo.